Have you ever wondered what happens when the world of the very small collides with the vast expanse of space? Welcome to the fascinating intersection where quantum physics meets the cosmos. This is a crossroads where the seemingly impossible becomes possible and the predictable becomes unpredictably fascinating. Quantum physics, the study of the very small, is a realm where particles can be in multiple places at once, thanks to the concept known as superposition. This is a world where a particle's state remains uncertain until observed, a world where reality is blurry until we attempt to measure it. Imagine for a moment a particle existing in two states at the same time. It's a bit like being both awake and asleep simultaneously. Quite a peculiar concept, isn't it? This is the strange and wonderful world of quantum mechanics, where particles can be both here and there, now and then, all at once. Now, let's take this unpredictability and apply it to the vast expanse of space. Space, the final frontier, the infinite void that extends far beyond what we can see or comprehend. It's a place of endless possibilities, a place of unending exploration. The principles of quantum physics don't just apply to the infinitesimally small particles. They also have implications on the grand scale of the cosmos. Because at the heart of it all, everything in this universe, from the tiniest particles to the most massive galaxies, is made up of these quantum particles. So when we talk about the collision of the quantum world with the cosmos, we're talking about a meeting of the smallest and the largest, the most concrete and the most abstract, the most understandable and the most mysterious. Now, imagine the oddities of quantum physics at play in the infinite expanse of space. Quantum physics doesn't just exist in a lab, it's in every inch of the universe. This statement might seem like an overreach, but it's not. Quantum physics, contrary to popular belief, isn't just a theoretical branch of science that exists only in research papers and the minds of physicists. It's real, it's here, and it's everywhere. Let's take a look at some real-world quantum phenomena that are not just fascinating, but also fundamental to the functioning of our universe. First up is quantum tunneling. This is when particles behave like little Houdinis, magically crossing barriers that, according to classical physics, they should not be able to. Imagine a ball suddenly appearing on the other side of a wall without ever having gone over or around it. That's quantum tunneling in a nutshell. Next, let's talk about quantum entanglement, a phenomenon so strange that even Albert Einstein called it spooky action at a distance. In quantum entanglement, two or more particles become linked and the state of one instantly affects the other, no matter how far apart they are. It's as if you had two dice, and no matter how you rolled them, they always showed the same number. This isn't due to any physical connection between them, but rather a mysterious quantum connection. These are just two examples of the bizarre and intriguing world of quantum physics. These phenomena aren't just scientific curiosities, they're integral parts of the universe we live in. They challenge our understanding of reality and push the boundaries of what we thought was possible. Quantum physics isn't just about abstract equations and complex theories. It's a key part of our universe, playing out in every moment and in every corner of space. It's in the stars above us, the ground beneath us, and even in the very atoms that make up our bodies. So the next time you gaze up at the night sky, remember this. Quantum physics isn't just happening out there in the distant galaxies. It's happening right here, right now, all around us and even within us. These phenomena aren't just weird science, they're fundamental to our universe. Space isn't just a vacuum, it's teeming with quantum activity. As we delve deeper into the cosmos, we might be tempted to think of space as a silent, empty void. But that's far from the truth. Space is not barren. It's buzzing with quantum fields. Now, what does that mean, you may ask? Well, quantum fields are the heart and soul of quantum mechanics. They are essentially the stage upon which all particles perform their cosmic dance. Imagine a serene lake. At first glance, it appears calm and undisturbed. But beneath the surface, there's a world of activity. Fish are swimming, plants are growing, and microorganisms are thriving. That's a bit like our quantum fields. On the surface, space seems empty. But dive deeper and you'll discover a flurry of subatomic activity. Now, let's introduce a concept that sounds like it's straight out of a science fiction novel: virtual particles. These elusive particles are constantly popping in and out of existence in these quantum fields. It's a phenomenon that's a bit like a cosmic magic show. One moment there's nothing, the next there's a particle, and then, just as quickly as it appeared, it vanishes. These virtual particles might be fleeting, but they have a profound impact on the universe. They influence the behavior of particles we can observe and measure. They play a role in everything from the stability of atoms to the energy output of stars. Yes, these tiny transient particles help shape the universe as we know it. This constant quantum activity means that space is never truly empty. Even in the vast, cold reaches of the cosmos, particles are dancing, fields are fluctuating, and quantum mechanics is running the show. It's a vibrant, dynamic, and decidedly quantum universe out there. So, even in the vast emptiness of space, quantum physics is hard at work. Gravity, the force that keeps us grounded, but in the quantum world, it's a mystery. Let's delve into this enigma. In the world we live in, gravity is a constant. It's the force that makes the apple fall from the tree, keeps our feet planted on the ground, and governs the orbits of planets around the sun. This is all thanks to Sir Isaac Newton and Albert Einstein, who provided us with a working understanding of gravity on a large scale. But when we enter the realm of the incredibly small, the quantum level, gravity seems to vanish. It's like walking into a party where everyone is mingling, but one person is conspicuously absent. That missing guest is gravity. You see, quantum physics describes the behavior of particles at the most fundamental level. It's a world of probabilities and uncertainties, where particles can be in two places at once or spin in opposite directions simultaneously. Yet, despite its strange rules, quantum theory works exceptionally well, predicting phenomena with astounding accuracy. However, when we try to incorporate gravity into this quantum party, things get tricky. Gravity, as we know it, doesn't seem to play by the quantum rules. It's like trying to fit a square peg into a round hole. The mathematics of quantum mechanics and the mathematics of gravity just don't mesh. This disconnect is a major challenge for physicists. It's like trying to read a book written in two different languages. You might understand the individual words, but the overall story remains elusive. Efforts are underway to bridge this gulf between the large-scale world of gravity and the tiny quantum realm. Theories such as string theory and loop quantum gravity are leading contenders in this quest. But as of now, a comprehensive theory of quantum gravity remains just out of reach. So, the quest to unite quantum physics and gravity is one of the greatest unsolved mysteries in science. Quantum computing might sound like science fiction, but it could be the key to exploring the cosmos. This exciting field of technology has the potential to transform space exploration as we know it. To understand why, let's first consider the challenges of navigating the vast expanse of space. The distances are so enormous, and the calculations so complex, that even our most powerful classical computers struggle to keep up. But quantum computers, leveraging the principles of quantum mechanics, could provide a solution. Quantum computers operate on a different level entirely. Where classical computers use bits, quantum computers use quantum bits or qubits. Unlike a bit, which can be either a 0 or a 1, a qubit can be both at the same time thanks to a quantum quirk called superposition. This means quantum computers can process a vast number of possibilities simultaneously, making them incredibly powerful for certain types of calculations. Now, imagine using this power for space exploration. With quantum computing, we could potentially solve complex navigation problems in a fraction of the time. We could calculate optimal routes, account for the gravitational pull of celestial bodies, and even predict unforeseen circumstances. But it's not just navigation. Quantum computing could also enhance communication. Consider the lag in communication between Earth and a Mars rover, which can be up to 24 minutes. With quantum computing, we could potentially develop quantum communication systems that are faster and more secure. reducing this lag and revolutionizing how we communicate with spacecraft. In the future, quantum computing could revolutionize our journey through the stars. As we push the boundaries of what's possible, quantum technology could be our guide, helping us navigate and communicate in the uncharted territories of the cosmos. The future of space exploration might lie in the realm of the very small. And indeed, it's the minuscule particles of quantum physics that could hold the key to our future journeys into the cosmos. Quantum physics, with its bewildering quirks and mind-bending phenomena, may seem like an unlikely candidate to drive space exploration. But it's precisely these peculiarities that could revolutionize how we understand and navigate the universe. One potential application of quantum physics in space exploration is quantum communication. This technology uses the principles of quantum entanglement, where two particles become linked and instantaneously affect each other, no matter the distance. Imagine, if you will, astronauts on Mars able to communicate with Earth in real time. No more waiting for signals to travel millions of miles. The potential for instant, secure communication across vast distances could transform how we explore and interact with space. But it's not just about communication. Quantum physics could also dramatically enhance our ability to detect and measure gravitational fields, a crucial aspect of space travel. Current experiments are testing whether quantum sensors can detect minute changes in gravity, which could help us map the cosmos with unprecedented precision. And let's not forget quantum computing. These super-fast, hyper-efficient computers could crunch through complex calculations needed for space travel in a fraction of the time it takes today's most powerful machines. They could help us design better spacecraft, plot optimal routes, or even predict space weather. But what does this all mean for the future of space exploration? It means that our journey into space might be powered not by rocket fuel, but by the strange and wonderful rules of quantum physics. It means that the secrets of the universe might be unlocked not by giant telescopes, but by tiny particles behaving in ways we're just beginning to understand. As we delve deeper into the universe, the world of the very small might just have the biggest impact. In the intersection of space and quantum physics, there lies a world of mystery and potential. We've journeyed together through quantum realities, taking quantum leaps to understand quantum space and gravity. We've seen how the microscopic quantum world intertwines with the astronomical scale of space, creating a fascinating landscape of scientific exploration. We've also glimpsed the future, where quantum computing could revolutionize space exploration, potentially opening up new frontiers and shedding light on the darkest corners of our universe. It's clear that understanding quantum physics in the context of space is more than just an academic exercise. It's a key that could unlock a treasure trove of knowledge and technology, propelling us into an era of unprecedented discovery and exploration. As we continue to explore both the vastness of space and the intricacies of the quantum world, who knows what fascinating discoveries await us?